Good afternoon. I think it's Saturday afternoon, post lunch. I hope everyone is energetic. So our topic for today's talk is concurrency versus parallelism in Node.js. It's one of kind of topic that is not covered by many of the people, and I would love to put my thoughts over this topic. So I've been working with Node.js for the past 3 to 4 years, and I'll explain, I'll put on my whatever I have uh, worked around with this topic. So it's me, Hrithik, Gavankar, and Rohit Bharmal. We both are software engineers at Red Hat. And yeah, so let's proceed to our first slide. Yeah, so it's a basic introduction to concurrency and parallelism. What does these mean actually? So in layman terms, concurrency is you could consider I'm in a kitchen, at the same time, I have 3 tasks to do now. I have to bake a cake, and cut some vegetables, fry some veggies, and at the same time also make some pasta. So it's only me who is cooking right now. At one time, I'll be busy with the oven. One time I'll just frying those veggies, and at the same time, one time I will be just busy with the pasta. So it's me who is juggling between these tasks, and it's only the me who's executing it. So this is what concurrency looks like in layman terms. And again, if that I compare it with parallelism, so it's you could consider it's me, it's my dad, and it's my mom. We three are involved in the process. It's me who is handling the cake to bake. It's my mom is handling the veggies, and my dad is looking after the pasta. So this is how parallelism looks in real world if I compare it. So so I think this makes it clear in a very layman terms. So yeah, putting this into Node.js. So we all know that Node.js is a single-threaded language by default, but due to its asynchronous behavior and the event loop, you could it's possible to behave it parallelly. You could see there is a main thread. That is what you observe. That's what JavaScript and Node.js works like. But it's also possible to work it parallelly when the worker thread comes into the picture. In the coming slides, I will go into deep in concurrency and parallelism. But before that, let's jump into what event loop is. That's a core of how Node.js works. So event loop will be covered by Rohit.
Yeah. Hi guys. So let's take a look at the event loop. So this is the overview of event loop, how it works and all. So it is a core mechanism in the Node.js or this JavaScript which runs the asynchronous as well as the synchronous operations. It enables the non-blocking input-output operations like network calls, data fetching, and many other operations at simultaneously without blocking any operation. So even though the JavaScript or Node.js, even though it's a single-threaded, it can maintain the high performance because of the event loop which runs in the background. So how it manages the task execution is there is a queue system for the call stack and the job stack, which runs in the background with the event loop, which enables you to do the non-blocking input-output operations. So I will go into the deep with the event loop, with the microtask and macrotask. But before going into the microtask and macrotask, what is async operation that Hrithik told about? So async execution helps in Node.js that to do the asynchronous operation. Let's consider you have a JavaScript application which has 3 functions, one for image processing, one for data fetching, and one for normal button click function to show the alert box. And these 3 functions are not entirely connected with each other. But if they are blocking each other's operation, there is no sense of making those applications because if they are blocking each other. So this is where the asynchronous execution comes in a play, where the input-output operations like reading files, network call, data fetching, any other normal call stack operations, they don't block entire applications. They run asynchronously and they runs the application smoothly. So in the background, the event loop manages all these things with the queue stack and the call stack and job stack. Because of this asynchronous behavior of the Node.js, it can handle many requests at the same time, and it keeps the app fast responsive even there are heavy loads. Let's go back again to the microtask what we are talking about. So this is the microtask. It is again a asynchronous task which runs after the current call stack, and it runs before the macro task. So there is a like precedence given to the like call stack, micro task, and the macro task. So first the call stack runs. After that, the micro task operations like the promises, mutation observers, async await functions runs, and then after that the macro task runs. So it executes right after the current execution of the call stack finishes, and it runs before the macro task, as I mentioned. So I'll go through this code once I finish the macro task one. Yeah. So my macro task is scheduled after the micro task and the call stack runs. There are like set timeout, set interval kind of functions, even the input output callbacks, they are there, which comes in like macro task. They can execute per event loop iteration, and they can like schedule like many more macro tasks also, but in the like future events group, not event loops, not in the same event loop. So if you look at the code there is a console log to print the script start. There is a set timeout function to log the timeout one. Then there is a promise. Then there is a set timeout, and again the console log. With the precedence, it should like how it written is like that. It should first print the script start, then timeout one. But because of this event loop and asynchronous behavior of the JavaScript, it will give the output of like script start first and the script end, because those console logs are in the call stack. After that, it will run the promise because it is in the micro task. Then it will like the promise 1 and promise 2, and after that the timeout 1 and timeout 2, which is in the macro task. So yeah, in the summary, the asynchronous execution, which is powered by the event loop with the macro task and micro task function, allows the Node.js to handle multiple operations efficiently. And we need to understand this model when we are building the like scalable applications and the responsive applications. Yeah, I guess Hrithik will take over with the concurrency part on this.
Yeah, thanks for the inputs on event loop. So exactly how the event loop works, and comparing it with the concurrency module. So until and unless our call stack is occupied, like it is what concurrency focuses is on is like executing the task, the only task at a time. So like even if some async operations are being executed, until and unless the event loop is keeping an eye on the call stack, until and unless the call stack is empty, it just pushes out. So it is executing just one task at a time, and only that task. So that simplifies concurrency. Coming to parallelism in action, like so parallelism is achieved in Node.js. There are multiple methods. So one of the methods what we see is the child processes in Node.js. So what in child processes does is it spawns multiple processes like each child is given some work to run in the background. So so it helps to not block the main thread. So the main thread is kind of free and responsive until that the child handles all the other tasks in the background. So it's like and it is not feasible for heavy operations, but some minimal operations like running a script or even a synchronous file writing and all is handled via child processes. And it can be achieved with 4 methods, that is spawn, fork, exec, and exec file. So like this all like methods are responsible for the child processes. And the second method is the cluster module. It's one of the heaviest used cluster methods to achieve parallelism. It is usually used in HTTP servers. Consider a Node.js server if a user is trying to communicate with the server. So to some extent or some amount of users, it will handle it brilliantly. But what if the number of users increase to like n,000 number of users? So it will fail to an extent out of memory bound errors and all. So here comes a cluster module. It's an inbuilt Node.js model which you could use, and like I've in the next slide I've just tried to replicate a cluster module. Like I've made use of the cluster, and since I've made use of the cluster, since I'm using my MacBook M3, so it has since it has 12, it is a 12 core CPU. So it makes use of the CPUs available, and approx 12 servers like the instances were up. For this, and also I tried hitting the same server using different tabs in my browser. You could observe that each had a unique server process ID, which was visible. So this using in cluster model, we could achieve parallelism. And the last one is, the worker threads. So after achieving parallelism in using cluster module and child process, if you need more granular multi-threading to achieve in Node.js, so worker threads is one of the responsible person, like if there are heavy CPU tasks, intensive, and like heavy computations. So here is where worker threads come into the picture, and it has high data processing and all, and you get the high command over the node and pool management and, like, using libuvs. And in worker threads, the memory is not occupied by its own, but it makes use of its parent memory. There's a method called as share array buffer, so it makes use of those for the memory task. So yeah, these three were the methods which are responsible to achieve parallelism in Node.js. And yeah, that's, I think, a wrap.
Yeah, so as we talked about concurrency and parallelism, right? So one of the great software developer, Rob Pike, has said that concurrency is about the dealing with the lots of things at once. Even the word says that the same. And the parallelism is about doing the lots of things at once. So yeah, it's Q&A time. If you have guys any questions for us. Yeah, hi.
So you have explained on the worker threads that they are sharing the memory of the parent process, right?
Choosing the shared array buffer.
Sorry, you have to repeat the question.
Yeah. So the question was, why does the worker threads use a shared array buffer? Like,
Actually, my question would be, do you need to implement some kind of very set mechanism in worker threads, or it's all built in if they are sharing like the same memory?
yeah. So what in worker threads, it's like, first I'll repeat the question. Yeah. So the question was, why is worker threads not using its own memory, and why do we require a shared buffer array in worker threads? So coming to worker threads itself, it creates instances of the whole, the whole thread. It has created instances of the thread, multiple different instances. So instead of making use of the own memory, it is making use, like, it's maintaining a parent and just sharing those array buffers with the parent. So using this, it gets more control over the memory management. So yeah, that's around what. Thank you.
Any other question? Yes. So these are all LinkedIn profiles. We are happy to connect with you guys. Yeah. Then yeah. Let's wrap up. Thank you.